give me a little update. So I know we did this yesterday, but let's just review. So whenever we do the null hypothesis, that is the part that is what is claimed to be true at this moment. And we went with Siri. So according to Siri, our null hypothesis, which we always call the hoe, it's all right. We might today, and we definitely will on Monday, talk about when and what's appropriate to reject the hoe. So get ready. All right. So, all right. So on this, the null hypothesis, and we'll actually talk about it today. Why not? All right. So on this one, we were told by Siri that the proportion of the water on Earth was 75%. All right, now, I didn't believe that. What was my alternative? So is that more than 75 or less than 75? All right, so whenever you do the alternative hypothesis, you don't ever give like an exact answer on the hypothesis. I thought it was 71. So you're either going to say like greater than 0.75, less than 0.75, or not equal to. I honestly thought it was less. So we would say P is less than 0.75. All right, and then we determined our test statistic was a Z or a T on this one. All right, Z was 1.96, and where did we get that from? All right, 95% confidence. So I am going to introduce a new Greek letter to you today. All right, it is alpha. We are going to say our alpha is 0.05. This is what we call the significance level. And where do you think I got the 0.05 from? What was our confidence level we used? So what we are going to do is, if we are testing a hypothesis at a 95% confidence, what we want to be true, or that alternative hypothesis, has to be outside of our confidence level in those smaller ranges. Yes, Jade?
This is kind of a random.
Uh-huh.
Why did they use Greek letters? Why didn't they just use A, B, C? Like, is that what it meant before? Yeah.
What?
Like, is that what that little fish
They
thing
aren't as
meant?
confusing.
Well, we've never used that fish thing before.
No, but like, is that what it means? Like, in Greek?
Greek means out. Yeah, that's a lowercase alpha.
So A.
Yes.
Okay.
I don't know. In statistics, whenever you are talking about just general things, they use Greek. Like if it's an overall population thing, they use Greek letters, and if it's a specific thing that you're collecting data on, you use regular letters. So that's like why whenever we calculate mean, sometimes we use X bar, but if we're talking about the mean of the overall population, we use mu.
Yeah. Also, I can't decide if you use an M or a U.
It's like a lowercase u, I think. Yeah. Yeah. So, no, but this is the new thing for today. So this significance level of 0.05, because whenever we're looking at this, whenever you're looking at a normal distribution, at 95% confidence, you're expecting the true proportion to be in this 95%, which means that it's 5% on the outside. So you expect your confidence interval, the values, to be within that. We actually, if we want the alternative to be true, we want it to be outside. Does that make sense? We want it to not be that. So we're looking for a significance level of 0.05. And then yesterday we talked about our conditions. And since this was a proportion, we checked it was random. The 10% population did show that it was independent. And we had 10 successes and 10 failures. All right, so we have those. All right, now we left this decision rule blank. And here's why. We are going to fill this in a little bit. our decision rule is, are we going to reject the null hypothesis or are we not going to? And we do have to, like, this whole next week, we're going to really focus on statistics language, because there's just certain things that you just don't say, because in statistics you never want to say anything with any sense of certainty. You can't ever like say it absolutely is this. We can say there's convincing evidence that that might be this, but we can't say it's absolutely true. Just because there is a little bit of wiggle room, and sometimes we make mistakes, and we'll talk about some errors that can be made whenever we're doing some of these tests that we're going to look at. So yesterday, what did we decide? What were our results? I kind of forgot them. How many?
72 water.
It was 72% water and 28% land. So what we are trying to figure out is this. Ooh, I don't know how to word this, but it's like it is less than 75, but is it less than enough to show that we have evidence to say that it really is less than? So is this enough to reject the null? That's what we're trying to find out. Is this 0.72 less enough from 0.75 to do this? All right, so what we are going to do is we are actually going to, we're assuming that the null hypothesis is true, but we're testing it. So that means that our p-value is 0.75. Do you guys remember how to find the standard deviation? Say it's something divided by the square root of n. What goes on the numerator here?
P times Q.
P times Q, and we are going to use the claimed value of P, not from our sample. We're going to test the sample in our curve. So on this one, we would take 0.75, what's Q? 0.25, and our sample size, how many times did we toss the ball? 100. So then this is where you guys can use your calculators. Find the square root of all of this stuff, and that's going to give us our standard deviation. And let's just do nearest hundredth today. When you plug all of this in, what is that standard deviation in the nearest hundredth? 0.04, I like it. So we have our mean, we have our standard deviation. So 0.75 is going in the middle. All right, so what values do we have going towards the right? If I add 4% each time, what am I working with? 0.79, 0.83, and 0.87. Now on the other end, it's 0.71, 0.67, and 0.63. So we've got a nice little curve. All right, so where are our results on this? All right, our results that we had from our sample was right here. This is our 0.72, and we want it to be obviously smaller than 0.75. So if we looked at this, what do you think the probability of this actually happening is? Does that look pretty common or pretty rare?
I'd say decently
Do you think it's,
common.
well, let's think about this. Our significance level that we determined earlier was 0.05. Do you think that when we do the normal CDF, this is going to be way more than 0.05, or do you think it's going to be less than 0.05?
Oh, more than 0.05.
It's going to be a lot more than 0.05. So what this is saying is getting 0.72 is pretty common. So even though it is less than 0.75, do you think there's enough evidence here to say it's less? You know, say, whenever we're doing a hypothesis test, we want whatever we're testing to be rare. We want it to say it's special. And if it's special, then we can change our mind. But here, it's, and I'll show you here in just a second exactly why we say this. But if we do a normal, we have our curve here. We can do a normal CDF to find out the probability of this happening. All right, what's our lower number? How far can this go down? Technically 0. I mean, we could put 0, we could 0.4 is like way off the range too. You could use a lot of things, but if you're not for sure, go down to 0. All right, now what's our upper? Where is our stopping point? 0.72. And our mean is our p-value, which is 0.75, and our standard deviation is 0.04. All right, so if we plug this into our normal distribution on our calculators, normal CDF, and we've got a lower of 0, an upper of 0.72, 0.75 is our mean, and our standard deviation is 0.04. All right, so I have to ask you, this is what we are going to, when we are doing a significance test, we just found a probability, correct? We found the probability that it's less than 0.72. This is, in a test, we are going to call this the p-value, the probability value that we find. And then we are going to take, like, I'm going to give you guys kind of like a little template on how to fill these out. But we want what we're testing to be rare. So we want it to be outside of our confidence interval. So if it's outside the confidence interval, it'll actually be less than 5%. This is way more than 5%. So this means that this is actually in our confidence interval. So therefore, since our p-value is way bigger than our alpha, we are not going to reject our null hypothesis. Fail to reject. We never say accept. Because really, do you think it would be appropriate to write that we accept a hoe? We reject it or we fail to reject it. Never accept. Accept is certainty. You know, so we just try to stay away from those words that mean absolute certainty. So on this one, whenever we go back to our decision rule, we can say that we fail to reject the null hypothesis because our p-value was bigger than alpha. So our 0.2266 was bigger than 0.05. So whenever it means that we are failing to reject, fail to reject means we can't say accept, but we can say we can probably go with it. We can probably assume that whatever it was true. Fail to reject means assume it's true. So on this one, we assume that 0.72 wasn't low enough. So we would say that there is evidence to support that the percentage of water on earth is 75%? So we are actually taking those probabilities that we were doing when we did confidence levels. You know, what's the probability that it was going to be greater than this or less than this? We're actually going to apply these to real life situations, and then based on those values and our confidence level, we will decide if we have enough evidence to support the null hypothesis or if we have enough evidence to support the alternative based on what those p-values are. So I actually want to today, before, I do want to show you one more thing about this. All right, let's pretend like you didn't know how to do a normal distribution curve. Although in order to get a 4 on a type of question like this, this is the type of work they want to see. They want to see that you know how to write a hypothesis statement. They want to see that you know how to check for conditions. They want to see the work, and then they want a conclusion. So there's 4 things that they will be looking for. Now, I do want to show you worst case scenario. If you forget how to do something, just build a confidence interval. So if we think about the confidence interval, wasn't that it? That formula is on your test too. So what was our p-value? 0.75. What was the test statistic? We talked about that yesterday for a 95%. 1.96, and then we can do the 0.75 times 0.25 divided by n. So if we plug all of this in, this is going to give us a range of acceptable answers that, yeah, they might be above or below, but they're acceptable. Now, if we had a value in our tossed yesterday that was outside of that range, then we would say, okay, we can probably change our mind. But if we look at this, if you type all of this in, so take your 1.96 times that square root, go ahead and enter that in and tell me what you get. So 1.96 times the square root of, in our case, our square root was 100. So we can go ahead and plug that in. I'm going to say, do you guys get something like that? So that means our margin of error is actually 8%. So that means that our lower value that would be accepted, what's 75 minus 8? 67. And our upper value, 75 plus 8, would give us 83. This would be a range of acceptable answers. Was our 0.72 in this? You know, say, was our value that we found on our tosses in that range? So since it was in that range, we don't really have evidence to support that it's not 0.75. So we were within the range, so we can't really change our minds. We got to support that it's 0.75. You know, say, I'm still not 100% convinced about that, but I don't know. Maybe I'm wrong. All right, so we do have one thing that I want you guys to write down, because Monday and Tuesday we are going to do a lot more testing of these things, because the more that we do this, the better we have the chance of getting 4s on these. And I will tell you, I've never seen a test that doesn't have a hypothesis test on it. You're never probably going to have more than one, but it might be a proportion, it might be a mean where you'll have to use a t-table instead of a z-table. It just depends, and we'll do a little bit of both next week, so that way we can get practice with those. But I actually have kind of just like a little cheat sheet. So this is where you might want a new piece of paper out, and I'm going to show you, whenever you are calculating a hypothesis test, in order to get that 4, everything that we need to include. Because it's like 4 little subsections. And I got to get a clean piece of paper because I'm going to write this out with you guys. All right, so you actually don't need your calculator now. All right, so how to show work for a hypothesis test. All right, the first thing we're going to do is we are actually going to divide our paper into fourths. Because there's 4 things we're looking for. Sorry, it's not focusing the greatest. So divide your paper into fourths, and then we'll talk about each quadrant and what you should include. All right, so the first thing that you have to do is write your hypothesis statements. So you're always going to have a null hypothesis. You're always going to have an alternative hypothesis. And then you would obviously fill those in with values based on the question. And then in this part, you always want to also label your test statistic and also state what alpha is going to be, your significance level. I cannot spell today. All right, so this is what we're looking for. Why is that not? There we go. That looks better. All right, so whenever you're writing your hypothesis statement, this actually isn't a lot of work. You're just stating what the null hypothesis is, what you believe the alternative is going to be, and then you name your test statistic and your significance level. Then, the second thing you always want to do is your conditions. All right, so these are different for proportions and for means, so I'm just going to put a little checklist for both. All right, so we just did a proportions one, so what are the 3 things that we check again? Simple random sample. What's the second thing? The 10% rule. Yep, 10 successes and 10 failures. Now with means, you still do the simple random sample and you do the 10% rule. But instead of 10 successes and 10 failures, what do we check on means? Not the sample size, and what do you want it to be bigger than?
30.
Yep, it's got to be at least 30. So depending on the situation, if it gives you something in percents, you're going to go the proportion route. But if it gives you something, you know, like a test score average or something like that where it's not a percent, then we go with the mean. Now that's not asking a lot. And just jotting down a little bit, like you don't have to do like a ton of work on those. Like putting SRS and a check mark is enough. But it's just showing that you understand that there's rules that you have to meet these things before you can do work. So then part 3. So this is just setting up. Now down here we're actually going to do some calculations. So if it is a proportion, you're going to do your mean And then you're going to do your standard deviation, which is P times Q divided by N. Now, if it's means, and it's back here. All right. The mean of our sample is the mean of the population. And then our standard deviation, we have to take the standard deviation and divide it by the square root of n. So those are just the formulas that you will be given on your formula sheet, but those are just a cheat sheet for you, and I'll try to zoom in. And does that look a little better? Sorry. So depending on the situation, first thing you always want to do is your mean and your standard deviation. And then we can make our curve. And then we do our normal CDF based on what we're trying to find, and then that gives us our p-value. Are you finished? Mm-hmm. Throw it in the box. I'll recycle it. Thank you. Have a good weekend. All right, so if once we do the normal PDF, that does give us our p-value. All right, so say these are actually, like, the hypothesis statement is technically new, but the conditions and the calculating part, we've been doing that. But now that we have, this is where we're gaining evidence. Now we actually can make decisions based on our results. So that's our very last step, is to conclude. Make a conclusion. All right, so with our conclusion, if our p-value is bigger than our significance level, we fail to reject the null. If it is smaller, so if it's rare, then we can reject it. And then once we decide if we're going to reject or fail to reject, we can write it in a sentence. And I'm just going to give you guys basically like a fill in the blank like we did with the confidence level one. So the first thing that we need to say is, assuming that the null hypothesis is true, or you would probably say I conclude. I always say we because we're always doing this as a group, but I conclude the p-value of blank. So you'll actually plug in your p-value. And then you're going to say whether it's greater than or less than the significance level, which is alpha. And in most cases, it's going to be 0.05, but if they give you a different confidence level, you'll use a different number. So this is just a sentence stating, I found a p-value, and then you say if it's greater than or less than your alpha. That's sentence one. Just stating what you found and telling me if it's greater than or less than. Now, sentence two is very simple. You either say you're either going to reject or fail to reject the null hypothesis. So now that you've told me if it's greater than or less than, then you tell me if you're going to reject or fail to reject. And then your last part, you're going to put it in context. We're not going to say it's true, but we're going to say there is convincing evidence to support, and then whichever hypothesis we're supporting. So we might say, like on the last one, we would say there's convincing evidence to support that the percentage of water was 75%. Because we didn't reject the null hypothesis, so there was evidence to support it. And so on this is where you are going to name the hypothesis you're supporting. And always remember, in order to get those full points, you have to use context. So like on that one, saying that the percentage of water on Earth is 75%, we talked about the water in the earth, talking about what the problem was actually asking about. So there's where we can get our point. So if you see here, yes.
Sorry, when you're done with this, can you go back up to the conditions?
Yeah. No, but on this, like each one of these, you're going to get E's, P's, and I's. So, like on your conclusion, if you have this, but you like maybe don't use context, you're going to get a P and not an E, things like that. So this keeps us, if you guys kind of have this template to follow your work, you're not going to miss anything. So we're just going to do lots of these to make sure that we're in good practice, because I know this is weird. Like, I don't teach writing very often. And so this is strange for me. Even though Mr. Boyd did ask me a grammar question this morning, and I knew the answer.
What was it?
He was wanting to know when you said, like if you're typing out Sullivan Middle School was capitalized. But then in a sentence later when he referred to the middle school, but it just said, it didn't have like Sullivan, like it was just middle school. And he was like, and I was like, no, you don't capitalize those. You only capitalize it if it's part of the name. But if you're just talking about middle school, it's not capitalized. I actually knew the answer.
That UMs isn't grammatically correct. He always says UMs, like UMs.
He does that all.
UMs?
Oh, it drives me.
Yeah, like
UMs.
UMs don't know what you're talking about, or UMs need to learn.
Yeah, he says that all the time. It makes no sense.
Hey, Jacob, is that what you were looking for?
Yeah.
Okay. All right, so we do have some more brackets in the last 10 minutes that need to get graded. So if we could divide and conquer those, that would be great. If you're still writing, you can write.